There's a YouTube video here that is really pretty great video just to show you interactively why the sum of the exterior angles does come up to be 360 degrees. See if you can check it out. I know it's not a copy-paste situation. If you look for it, it's really good. Definitely worth the watch. Maybe I can show it in class. As I go to this one, the next slide, you're going to see a polygon is something that has many angles. Poly means many. A convex polygon, no line containing a side of the polygon contains a point in the interior of the polygon. I think the best way for me to describe that is interactive. Here I have a polygon ABCD. I can move it. This is convex right now. And you can see I colored the interior in a different color. So this is a convex polygon because you can see the lines that contain the sides are not going in the interior. Once I do something like this, now polygon ABCD is non-convex because you can see the sides that contain AB and the line that contains side AE. Their lines are going through the interior. So if you want to kind of draw a sketch of those in your notes, this is an example of a non-convex polygon, because if you drew a line through a side, that line would go through the interior. Here's a convex. Non-convex, convex. For the other two, hopefully you found in our exploration, you kind of discovered where these came from. For the measures of the angles of a convex polygon, the interior angles, n minus 2 times 180, where n is the number of sides. And again, you can put that exploration in your notes. That's where we found it. We found it from looking at a number of triangles. Okay. In the next one, the sum of the exteriors, you should have found to be 360. And if you go back and watch that video, you'll see a really cool display of why that is 360. And what we're going to be doing with these is we're going to be looking at regular polygons. Whenever I say regular, that is already telling you it's equiangular and equilateral. So a regular triangle is equiangular and equilateral. If I say a regular pentagon, simply by using the description regular, I'm telling you all the angles and all the sides are equal. So on our next screen, notice that I said they were regular polygons because yes, this could change, but I'm defining them as being regular, equilateral, equiangular. I want you to find the measure of each interior angle and each exterior. So only one, not the sum of the interiors. How many one interior would be and how much one exterior would be. So I'm going to let you try and do this. I really would like you to pause, try it on your own, then come back and check and see if you got it right. At least then you'll have thought about it. If you made a mistake, you can correct it and you'll learn it better because you did it that way. So try these three, and you're also, if you haven't printed them out, you're going to try these two. Now notice in these 2 and 4 and 5, what I gave you, given the measure of each exterior angle. So the 10 here is the measure of one exterior angle of our polygon. You need to find the measure of each interior and the number of sides. So give it a try. Like I said, the ways I'm going to show you, there's definitely more than one way. Do the way, kind of think about it and work it out in your own way. So push pause. When you have finished attempting these problems, push play again. All right, so hopefully you've tried them all. I kind of drew a quick little sketch here to remind you that when we did interior and exterior angles, by angle addition, those are supplementary. So you're going to see me using that here. Maybe you figured that out and used that. Again, the way I'm doing them here may not be the way you did it, but there's more than one way to do it. So for 6 sides, I did the sum of I found each interior first. So I used the formula 6 minus 2 times 180. I found the sum was 720 and then divided it by 6 to find each one. Then I used the fact that I used the sum of the angles was 360, the exteriors, divided by 6, so each exterior angle is 60. For the next one, I believe I did it backwards. Okay, so this time I found the exterior angle first, doing exactly what I did before. Then I found each interior by using the fact that the interior and exterior were supplementary. Yes, you could have done it this way too. I'm just trying to show you many different ways you could have approached it. In the next, with the 20, I did this again. In this one, I started with doing 20 minus 2 times 180, which is the formula, doing it like we had started with number 1. And then for the exterior, what I did this time was I used the fact that they were supplementary. Also take a minute here. As the number of sides increased, look at the interior angles. What do you see with each interior angle? Hopefully you say they're getting bigger and bigger and bigger. And the exterior angles are getting smaller and smaller and smaller. In the next two problems, find the regular polygons. So again, I did it in a couple different ways. Over here, I kind of used the exterior angle equals 360 divided by n. I solved it where n is the number of sides. And then used the fact that the exterior angle is 10. The interior angle is supplementary to that, so I used that there. Okay, here I did the interior angle first by using the fact that they're supplementary. And then I said, well, listen, every time I'm finding the number of sides, I'm just doing 360 divided by the exterior angle. So I found that there. In the next one, again, I'm going to ask you to work on these, then push pause. This time I gave you the measure of an interior angle. Notice it's a little different. Interior angle, your job to find the exterior and the number of sides. So give that a try and push play when you come back. All right, over here. To find the exterior angle, I just used the fact that the interior and exterior were supplementary. Use that relationship because it seemed easier. And then just did 360 divided by 1 equals 360 sides. This one I did the same thing. To find the exterior angle, I used the relationship that they were supplementary. And then took 360 divided by that to get the number of sides of 4. Okay? And this idea is used quite a lot for the rest of the year in geometry. I would also like to encourage you to please go to Canvas, and on the calendar I will have your homework assignment. So I'm going to expect this to be done for Wednesday. Okay? Have a great day.